Hello and welcome to the first video of the Answer Me channel. Today, we're going to look at probability. So today we're going to look at tree diagrams. This is a three-part question. This is part one. If you want to find part twos and threes, there'll be links in the description below, or you should probably see them on the side. Now, the number one biggest thing that I tend to see with probability is misreading the question. So in this video, I'm really going to emphasize that, and we're going to step through how to make a tree diagram. Because if you might not be the most confident at probability, or probability isn't your first love, then the tree diagram is a sure and safe method for you to get your probability questions. So let's read the question. A student is given a box containing 3 green lollies and 5 red lollies. She chooses 2 lollies from their box. The first one is not put back before the second is chosen. Find the probability she gets 2 green. Okay, so a student is given a box containing 3 green, let's just mark that there, and 5 red. This is important. This means we have a total of 8. Okay, so our total is 8 and we have 2 colors. Okay, let's keep reading. So, is given a box containing 3 green and 5 red lollies. She chooses 2 lollies. Okay, so 2. That's how many steps we have from their box. Okay, so it's a 2-step problem. Okay, then the first one is not put back before the second is chosen. Okay, this is important. This is the most important part. Well, one of them. Because what this is it's telling us it's not being replaced. I emphasize the not here. It's not being replaced. So she takes one and then takes another. She doesn't put the second one back. Now this changes our probabilities a bit. Okay, before the second is chosen, find the probability she gets 2 green. So let's start this with the sure and safe method of using a tree diagram. Okay, so with our tree diagram, each of the branches represent a different possibility. So at this stage, if we start with our box here, we have 2 possibilities. Actually, let's move that here. Box. We have 2 possibilities. We can get a red, okay, or we can get a green. So green, red. Okay, 2 possibilities there. Now, let's say we got a red. Then we have another 2 possibilities for our second one. So this is step 1, step 2. We have another possibility, and that is we either get a red, so we take a red out and then we take a second red out, or we take a red out and then we take a green out. Okay, now same thing down here. We can take a green and then we can pick a red out. Okay, or we take a green and we pick a second green. There we go. So there's our tree diagram. But there's yet one thing missing, and that is our probabilities. Now, you can pause the video here and try to add the probabilities in yourself, or we'll go through them together. So, what's the probability of getting a red lolly? To get a red lolly, and to find any probability for that matter, we put what we desire over the total. Okay, so in this case, we want a red. Okay, so how many reds are there? There are 5 reds, as you can see. 5 reds. So this means that we want 5 reds over the total, which we talked about, which was 8. So that's 5. That's 5 on 8. Good. Now, what about for this red here? Okay, what is that red going to be? So, we've already picked a red up. Now, how are we going to get this second red? So this second red has one less red because we've taken one here, and it has one less overall because we've taken one out. So here we're left with 4 reds and 7 total. So we've taken a red out, so there's one less, and we've taken one lolly out, so there's one less than the total. So if we apply this formula here, what we want, 4 reds out of our total, 7. Okay, now what about for green? Do you want to try for green and then pause the video and see if you got it right when I work through it? Okay, so if we have 4 reds and 7 total, that means we still have 3 green lollies left. Now, we didn't take any greens out, which means that there wouldn't be any difference between here and here, between the red and the green. This means that we can do 3 greens. So what we want, 3 greens over the total, which is 7. So for this part here, it's 7 total. So this is going to be 3 on 7. Okay, now what about for this second green? This second green, well, first green for this branch. This first green is going to have the probability 3 on 8. Why is this? Because what we want is 3 out of our total is 8. Now, you might be wondering, but we removed some greens here. Yes, but these two are completely independent. Okay, so this can happen or this can happen. So this can happen here or this can happen. This branch here or this branch here. So we start afresh on every single branch. So we're here. We have a green, which we have the probability 3 out of 8. Now, this red attached to the green, what's the probability for that? The probability for this is going to be 5 reds over 7. How did we get this? If you recall, we didn't take any reds out on this path here, but we took one green out. So our total is going to be 1 less than it was. But we took no reds out, which means our number of reds stays the same. So what we want stays the same, but the total decreases. Now, what would the probability for the green be? So the probability for the green is 2 on 7. So just as we did up here, green, we remove one here because we've picked a green up, and then we remove one from the total because we picked that green up, so we're there. Now, with tree diagrams, the probability for any one of these branches, so this branch, this branch, this branch, or this branch, is going to be the probability of this times the probability of the two next branches. So the probability of getting two greens is going to be 3 on 8 multiplied by 2 on 7. So what this is going to look like is 3 on 8 multiplied by 2 on 7. So that's the probability of our first green. And that's the probability of picking our second green. So that's going to equal 6 on 56. Now that we have that, I think I'll leave you with a couple of questions. So what is the probability of picking two reds, or conversely, no greens? And what is the probability of picking one green and one red, in whatever order? Thank you for watching. If you want to see the answer of these, hop on to the next video where I'll be explaining them. Hop on to answerme.com to vote on the topic for next week's series of YouTube videos. Thank you very much.